How's it going there, Mike?
Hey, what's going on? How are you?
I'm doing well. Thanks for joining today.
Absolutely. Absolutely.
I'll put one more post up on LinkedIn here. Any stragglers?
Yeah, I'm excited to hear about things.
Yeah, absolutely. So did you just see some of the posts on LinkedIn, or did I connected with you, right?
Yeah, we connected, so I checked out your profile and saw what
Awesome.
you're doing. Very cool.
Yeah, we should have a few more people joining us. We're a couple minutes early here.
No worries. I'll keep on coding while we're
Yeah, man, there you go. That's how I like to roll.
Yep.
Coding as much as possible.
Always coding.
So I'm gonna pop up one of these projects here. Let's see, I might grab the Pixelfest devs page.
Loving this.
And what the hey, might as well do Twitter as well.
What's that?
So I'm just throwing out a quick reminder for everybody.
Yeah, no. You can let some folks take some time to show up. It's totally cool. I can hang until we're ready. And if it's just you and me, that's all right too.
Yeah, that'll work. That's all I've been doing. There's just one-on-one developer chats up until this point. This is the first sort of group Q&A. One of my fellow entrepreneurs from the Hampton Roads area actually recently moved to Arizona. Xerxes and Bong said, why don't you do a group Zoom and get more people chatting about it, more ideas going? And I was like, you know what, that's a great idea.
Yeah,
You
no,
set
it
that
is.
up.
Good to hear what other people are working on too and how it could apply to them, you know?
Oh yeah, absolutely. So yeah, what project are you working on right now?
I'm working on actually a game that this really wouldn't apply to currently because it's a single player action adventure RPG.
Oh, nice.
But you know, plenty of other places where this could be hugely useful for sure.
Yeah, I've been. Oh, go ahead.
I was gonna say, unless of course, you know, I wanted to build in some kind of like a streaming functionality just for broadcasting your gameplay, but there's lots of options for that. I think it would be cooler to implement this in a way for people to actually play games together, you know.
Oh yeah, for sure.
Platform.
I'm glad that it sounds like you sort of see the possibilities. You know, some people are like, well, what am I going to use that for? And there we go. Chris joining us.
Well, you have cross-platform publication with Unity, which is a huge advantage of it. So why not implement cross-platform multiplayer playability too? You know, I mean, that's huge.
Yeah, and man, it makes it simple too because you don't have to write a lick of netcode to do it. That's the greatest thing about it. I mean, as long as you're doing some sort of, but I don't even know if it has to be a single screen game. It's going to be interesting to see how it morphs as people use it for multiplayer gameplay.
Totally.
I like using it for SwapFire, which was a split screen game that I developed for the Wii U. And now I've got a version of that up and running, just ported to the PC and basically broadcast the split screen view, and 4 players can join from anywhere in the world on any platform.
That's awesome.
And then, I don't know if you saw that Turtles demo, but took a Super Nintendo emulator, basically encapsulated that inside of Unity. And now we can play Teenage Mutant Ninja Turtles 4, Turtles in Time, online multiplayer, which is pretty cool. Could throw like video chat and stuff inside of it as well. So those are some of the things I'm experimenting with.
Awesome.
And I think Chris is working on some games as well, if I remember correctly.
I'm working on a card game.
Oh, nice.
Where the players are going to have webcam and voice chat.
So that's also a really good use case, especially if it's people need to like read poker faces.
Yep.
Like that. So that makes a ton of sense.
Something like this is so extremely necessary in a time like this as well, right? Like, this is the time for games like this.
I actually just made this thing. So one of the other guys who should be joining, at least to listen in, he said, you need a slick sheet for this thing. And so I created one for enterprise, which, to tell you the truth, I think for the most part in the past, people that have used this were enterprise people. And of course I see the possibilities for gaming, and I want to build a gaming platform using it, but this is a slick sheet that shows, sort of the gaming possibilities, I guess you could say. And so we got Mario Kart, SwapFire is right here, basically just saying, hey, the world has changed, Yep. Don't want to move that. But everything is online now. And we sort of went from this period of time where, a lot of people were playing online. I mean, even when we made SwapFire, I chose to make a couch multiplayer just because personally I had the best memories with couch multiplayer games in the past.
Right.
I kind of wanted to start there. I also, at the time when I developed that, I didn't have StreamSDK to the point where it is now. But I wanted to create something where I didn't have to worry about, writing all that net code and maintaining that online infrastructure and, maybe having to shut part of the game down. The cool thing about this, though, is you can just have that game that's couch multiplayer, and you can set up this online infrastructure to play it online now without having to worry about writing any net code, without having to worry about really shutting the whole game down or shutting a whole aspect of the game down. You could just say, okay, well, if you want to shut down your online infrastructure, it's a switch where you're like, okay, you can't do that, but you can still play it multiplayer. And it's not like this huge chunk of your game. It's literally just the flick of a switch where I'm either going to take that single screen game, multiplayer game, and make it online or not, which is much easier.
The couch co-op game now becomes controllable from different places.
Yeah, that's it. Yeah, you're literally just accepting inputs and then you're sending out audio and video back. So,
but we see how it's possible over a nice fast internet connection for something like Google Stadia to literally be running the game somewhere on a server in Denver, and then accepting your controller inputs and then streaming the game back to you all in real time with very little latency. I mean, why couldn't people reasonably be playing the same game at the same time on the same screen with very little latency?
Mm-hmm. And it works. I've actually tested this. One of the guys I invited, I don't know if he'll join this guy. I think it's like 2 a.m. where he is. He's in Singapore, but we played the Tanks demo together, and that was 11,500 miles away. The network server was running out of my office. The caster was actually running in Singapore. And we played a multiplayer, 1v1 tank game, and I was able to control it just fine, even though my inputs were basically being routed through my server to Singapore to his caster. That's where the action was taking place. And then the audio and video from his caster was being sent back to me, and I was totally able to play the game. And that's as far away from each other as you can get on the globe. So,
oh, yeah.
Wow.
Pretty impressive.
And being able to do it P2P is cool. I mean, if you want to host this in some sort of cloud environment, you can do that. But yeah, you can do it P2P. Oh, there's Nathan. Welcome to the chat, Nathan. Thanks for joining us. Got to keep an eye on admitting people. Oops. That's not what I wanted. There we go. see who else joins us. So I was putting up that this was, I want to shout out to Nathan, say thanks for giving the idea for doing a slick sheet. This is one sort of on the gaming side, and then there's another rendition of this, which is more for our traditional, use case, which is a little bit more on the enterprise side. So this is something I'm working on. I haven't really put these out publicly yet, but this focus is a little bit more on the enterprise side. Some of the people that have used it. I have to edit this list actually. And that one focuses a little bit more on, I think, the security aspects of it. And one of the things that I'm saying is that philosophically, the idea is that our computers can share their speech without necessarily sharing their thoughts. There's thoughts sort of being like the files and source code, source images, all that type of stuff. Those are sort of like the computer's thoughts. And then, the computer's speech is the AV and everything that comes out. So that's right. I'm working on it. That's kind of what I'm thinking about philosophically.
It's an interesting way to describe it. I like that.
Yeah, it kind of helps. Let's see. I feel like I lost my. I do not. I feel like I don't use Zoom enough, which is crazy to say that because I use Zoom all the time. Here we go. One walking. How's it going? 141720. How's it going? Who do we have there?
We don't know.
Is that Xerxes? You might just be listening. So we're getting some people on the call, which is good. And I have one project open here. It's actually the retro project. I've been working out of this project a lot. I think as I've posted the TMNT stuff up there, and it just makes for an interesting project. And there's so many different use cases for streaming. And this one just happens to be a fun one that I've been dabbling with. So I like to use it as an example. And basically what we have here are, there are two scenes that we'll focus on. One is a stream or caster. Sometimes I call it a caster. In this particular case, I use the term stream there, but essentially you have a caster that's running, it can be a game, software application, whatever it might be. And that caster is going to send out its audio and video to any clients that join. And the caster and the server, in this case, they don't have to be one and the same thing. I mean, you could run the server off of the caster, but the server, right now we're focused on Photon, so we usually have a Photon self-hosted server. That could be hosted anywhere in the world. The caster could be hosted anywhere in the world. And then you could have controllers join that caster also from anywhere in the world. And in this case, and I'm going to boot this thing up and see what happens here. Everything is impromptu right now. So I'm just sort of diving in. The first thing we see when we pop this open is the StreamSDK Shell. You do not have to use this if you don't want for your project. If you want, you can actually, I'm going to dive down here into the tool folder under StreamSDK. There's this thing called Auto Start, and this provides you an example of how to get started really quickly and sort of skip the shell if you don't want to use the menu. The menu sort of helps, I think, provide you with some context for what StreamSDK can do. If you jump into the options and go to audio, you can see some of the audio options you have available to you, some of the video options you have available to you. And of course, the documentation will dive into a lot more depth, network options. And this is just kind of a quick way to sort of putz around with it and poke and prod and see what it can do. For SwapFire, I didn't want to use the shell. I just wanted the SwapFire game to run as if it were running on a Wii U, and then have people instantaneously join it. And this shell doesn't appear anywhere in it. The game's just running, and whoever joins it can just take control of the game as if they're there. And so that's kind of where the auto start came from. And you can see it's just a couple lines of code just to get things rolling. In this case, though, we are using the shell, and some of the things I want to point out, you see this red text. We'll shut down the stats here, but you've got the red text in these upper left and right-hand corners.
I'm not seeing any video at all, Jeremy.
Oh, let's see what's going on here. Screen share.
Yeah, hey, this is Nathan. Yeah, I'm not seeing it either.
There we go. Got it.
You guys didn't see any of that stuff.
Perfect, thanks.
I thought I had my screen shared by default, but so great.
You painted such a good picture with words, I didn't need it.
So let me show off this slick sheet again. And again, thanks to Nathan. So since you guys didn't see that, here's the slick sheet. So this is kind of what I was describing before.
This is cool. Yeah.
Just sort of showing this off, and I can send this to anybody that wants to take a look at these. And we have an enterprise version as well. So I was saying in the past, a lot of customers were more on the enterprise side than on the gaming side, but definitely gaming is going to be a target. Let me see if there's anybody else who got to let in here. Like Zoom trips me up. Where are my controls to let people in? If anybody else is trying to join, I'm sorry. I feel sort of Zoom illiterate at the moment. So I had a nice little window to, there we go, participants. All right, we don't have anybody else. So let me get back to Unity though here. And all right, so you guys have video now.
Yeah, you got good.
All right. So this is what I was describing, which is the shell, and I was talking about the auto start component, which is down here if you want to just dive right in and sort of skip this. But the shell, it sort of points you in the right direction as you're going to be developing user experience for your users. In the upper right-hand corner, we're seeing some usage statistics basically come off of, let's see, under shell. These two components here, we've got the StreamSDK error debug and the usage debug. These basically are going to tell you, hey, are you using a platform that you don't have a license for, or is there no internet connection, things like that. And then I was poking and prodding around the options, so the shell will give you rough idea of the kind of options that you can control with StreamSDK on the audio, video, and network side. And then, of course, this is a retro demo. So this is the Teenage Mutant Ninja Turtles 4, Turtles in Time for the Super Nintendo. And this is the casting scene. So I think I literally just took the car demo and then modified it for this. So StreamSDK by default comes with a base 3D demo, car demo, character, and video chat demo. So I took the car demo as a casting demo, and that's where I started with. And so if I hit car cloudcast there, and hopefully it'll work. Oh. It'd be better if I turned on the server. See how quickly that server boots up. So the server in this case is just running off a Windows box that I have in my office. And I'm actually running this off of Mac. Let's see.
I'm pretty sure the answer is yes, but like so I guess the server and the client are both cross-platform?
Yes, so it's all, and I think that's the big thing, is it's all cross-platform. Any platform that Unity supports, this supports. And as we develop further and further, we do have some special features that aren't necessarily available on every single platform. Let's see here. Did I break something? But in general, yes, you can get some sort of completely cross-platform. So I'm getting, is this having a hard time?
Say, including Linux. You know, there are those of us who do love our
You should,
Linux VMs floating around in the cloud somewhere.
I don't have a Linux
Sorry,
bot,
go ahead.
but it should work on Linux. And Linux, I think every feature should be supported on Linux. It's one of the platforms on my spreadsheet and I go through. I haven't actually tested myself. There's a couple of platforms that I haven't actually gotten to test myself, but theoretically should work. I'm getting...
Cool, that's good to know.
I wonder if this is... I'm going to quit out of this real quick and come back. I seem to be getting some bad data back from my server. Let's see if anybody else is, we got somebody else trying to join. How's it going there, Kevin? Good to have you on board, man.
Hey, how's it going?
Good, good.
Awesome.
So Kevin Co is with 900 pounds, and they've been doing some pretty deep integration with StreamSDK. And I think I was explaining Xerxes Nabong's a guy who I was chatting with last week, and I was telling him how I had been doing these one-on-one calls. And he said, "Why don't you do a group call? Get more people asking more questions at one time. Record that and share it." I was like, "That's a great idea." So I appreciate everybody being here. And now what I'm going to do is dive back into this and make sure I can actually run. So I'm getting, oh my gosh. I don't know. I wonder if this is because, I wonder if I have a bad API key in here. Gotta get my keys. Let's see here. So this is great. I'm getting a new error that I haven't seen before as I try to run this demo for you all.
I think we've all been there.
What's going on? Fantastic. And I don't know if it, I haven't done this on a Zoom call before. I mean, Kevin and I have done some work over Zoom, but let me grab my keys real quick. Make sure my keys are right. They should be fine.
I mean, I don't know if, like, I guess while you're troubleshooting, I was kind of curious. Kevin, could you tell us, I mean, would it be reasonable to tell us a little bit about how you're using it?
Yes.
Or just at a super high level?
Sure, yeah. 900 pounds, we mainly make sort of complex UI, and we take our client's data and we basically display it in a visually wow sort of way. And that's the gist of it, and we mainly use a lot of touch interaction things. And this context is important because, well, because of the recent outbreak, nobody's going to want to touch an interactive display for a little while. So we reached out to Jeremy here because we found out about StreamSDK and how we're using it in one of our applications. Just as a test, is basically we're taking an application that was 4K, that was designed for a 4K interactive touch display, and basically porting that over to be hosted on a self-hosted on a server. Right now we're exploring that through Microsoft Azure, self-hosting on there, and then basically just having controllers launch, sign in, and join the stream with the multiple user inputs. And that's how they're interacting through the app.
That sounds super cool. I'll definitely have to look up your company. I could see the appeal of that sort of a service.
Yeah, and right now I think we're trying to see, because you know there's obviously going to be some bandwidth limitations. The stream so far we found the best frame rate at 720, but hopefully with the new encoder that Jeremy has been talking about, we'll be able to bump that up. So that's what I'm most looking forward to for this one.
You should be able to get the same performance, I would say, out of 1080p now is going to be what you were getting with the 720. So you should be able to actually crank that up to where we were working before, and hopefully get, essentially double the performance at 1080p that you were before.
Right. And, as convenient as a WebGL build would be, I think we're now starting to realize that, well, that's going to be really inconsistent on the client's end because, through a browser, it's only going to be able to use their CPU, while through an application, they're going to be able to get way higher. So, yeah.
I think I know what my issue is. And I may have inadvertently I know exactly what happened. So I had I was working on this as version 3.1.2 as I was going to release it. And as the release went along, it really wasn't a minor release anymore, or it wasn't a release. It wasn't a revision, I should say. And so I bumped it up from 3.1.2 to 3.2, but the DLLs in this project weren't updated yet. So I need to go fix all of them. And that's the issue that's going on here. So we're live troubleshooting as we go here, which is always fun.
Okay. So that
I'm like, why can't I connect?
updated on the website?
Oh. So I just had to drag and drop my DLLs from the actual project that I put up versus I'm in this retro project right now, which I wanted to share. And screen platforms, cool. What we got here? Include. All right, great. Let me try again. Before I share it on screen, let me just make sure I debug that properly. Yay! All right, sweet. So yeah, that was the issue there. And then Zoom is still, in some ways, I feel like Zoom is still a mystery to me. Where did my little control panel go?
I have no.
Come on, Zoom. Where you at? Oh, there we go. There's a lot of places to reach it, which is cool. So it's a little bit like Unity in that way. They come up with 3 or 4 ways for you to reach something. All right, so you guys can see Unity now. And I was wondering why I wasn't seeing the proper numbers up here, but there you go. So this is your usage information. This is, if you have any errors or anything. I was noticing as I was working, there were some getters in the StreamSDK library so that you can figure out if, you don't have a certain platform, there's no license for that platform, or, you're on a version that's obsolete or deprecated, something to that nature. So that's all documented, but as far as controlling the user experience and letting people know right away, that stuff wasn't as overt probably as it should be from a development standpoint, from like a developer experience standpoint. So I added this version just to make it a little bit more apparent, because there were some times that I was running versions and I couldn't remember whether I'd given myself a license. And then all of a sudden I was running into, what seemed like glitches, but it was really just because I didn't have a license for Android or WebGL, and I had to go in and give myself a license to test. And so these things will sort of keep you queued in. And then obviously if you're building an app with this, that was a production app, you'd want to integrate that a little deeper into your user experience, but that's kind of what's going on there. So as I was saying, this is the TMNT4 demo. I don't know how this is going to run over Zoom. And maybe it doesn't like running with Zoom. Let's see, I'm going to switch my can it like running with Zoom? Nope. turn these off. And I was also working on Android last time, so switch platform. This is one issue. If you're developing with this, there are a few DLLs, and now there are more DLLs to deal with. So there are 3 DLLs, one for Windows, one for basically everything else, and then one for WebGL. And Kevin, I think the version you were working on, we just had one for everything and one for WebGL. And now there are a couple more DLLs that go along with the new encoding, the new compression. And so managing those properly and making sure that you have the right, essentially DLL selected for the right platform or whatever is important. And I'm hoping that what I just had was a little, just got to check these things. Make sure I've got the right DLL selected for the right platform. And I'm on a Mac right now.
So while you look at that, Jeremy, are there any external dependencies, any software that needs to be installed alongside this, or extra licenses or anything like that?
So right now, I can probably keep that up a little bit. There we go. Good old TMNT running inside there. And do I have the new stuff running? Yeah, cool. So as far as dependencies go, right now it's built assuming that you're going to be installing Photon free classic Unity networking, or Unity networking classic, whatever they're calling it. So that's sort of their previous network software. You don't need to use that if you don't want to, but this version of StreamSDK, that is basically how everything is built. We provide a wrapper for Photon. Now I do have a wrapper for TNet if you want that, and that's something I can send you. I'm currently not putting it in the package because the last time that I used it successfully was at the end of 2018. And when I went to use it this past summer, as I was preparing StreamSDK for, basically getting it ready for what was going to be the final stuff, I decided, you know what, I'm going to just focus on Photon right now, and we'll put that out later. So right now, if you come under the StreamSDK tool folder, and you guys can see the screen right now, right?
Yeah.
Yes.
Yep.
Are you guys seeing the screen?
Yeah, we can see it, yeah.
Hello? Oh. Let me turn the game audio off so I can actually hear you guys here.
Okay, so I guess Photon is it a free distribution from Unity?
Yes, so right now you can still get this version of Photon, the one that this was built on, or the one that it's not really built on, but it's the one that sort of works in conjunction with StreamSDK at this moment. It's free right off the Unity asset store. And if you go over, I think 100 users or 100, I'm trying to think what their limits were. They've got some limits on the number of simultaneous players that you can have connected. If you went over that, you'd get yourself into a situation where you have to pay. So it's really aimed at large scale multiplayer games is what their target audience is. And they have a cloud version of their software, but there are heavy restrictions on that. As it was made for multiplayer gaming, not for streaming, they really limit the amount of packets that you can send and also the total bandwidth that you can send. So it's not really the greatest thing for streaming audio and video. It works, but you're going to want to install their self-hosted server. And so right now I'm running this game, and you can see here we're streaming at 60, 70 frames per second, even close to 80 frames per second with Zoom on, and we're recording the screen right now. So got really great performance, and I can stream this game at over 60 frames per second now. But in order to take advantage of that, I need to run my own server. And so I've got a Photon self-hosted server that's just running also here in my office on a Windows box. I think it only works on Windows box right now, but the source code may be available for it, so you might be able to build it for other platforms if you want. But essentially, I recommend using that Photon self-hosted server, and all of that can be used for free out of the box. And the limits as far as streaming goes, are pretty, I think, there's a lot of freedom there. They're liberal limits as far as using this for a streaming application goes. And so I'm imagining Kevin and everybody at 900 pounds, you guys are going to host that up on Azure. So you'll have to pay for whatever the bandwidth is on that cloud service. But the server itself, you probably won't be streaming to more than 100 people simultaneously. And you don't have an issue there. And even if you wanted to set up multiple instances, you could actually route clients to different servers if you wanted to break that up, as long as you weren't going over 100 clients simultaneously from one server. You can get a lot of scale out of that. So it's a very reliable service and system. There's some other networking protocols that I really want to get into. I want to add, like I said, add TNet back. And if anybody wants to take a look at that TNet wrapper, I have that available. I don't include it in the package right now since it doesn't work out of the box. But I think I put on the roadmap that I'm going to get back to that. I want to take a look at doing a web RTC implementation for this. I think that would be really helpful. And there's some stuff that I'll turn my attention to. I feel a little bit better with the encoder working at this level of performance now, and feel like I have a little bit of breathing room there, although I've definitely my eye on whatever the next level is going to be. So yeah, networking though is freedom, I think. And so the more options that you have for different networking tools or protocols, libraries, the better, so that you're going to find something that fits. Photon just happens to be a really good, reliable, easy solution. I think it's the one that works on the most platforms. They have all the console players. So if you're making a console game, you'd be able to use Photon. And, Photon is Nintendo approved, stuff like that. So they seem to be a good sort of first go-to. And StreamSDK was designed though in such a way that you're not limited to them. It's just, it's just an easy button to push. So that's why I used it.
Great info. It's good to know that you got some flexibility, because you never know what your client requirements will be when you're designing a new project.
Yeah, absolutely.
Right.
There's, everybody's got something different, and it seems to me that leaving that open to people was really important, because you don't know what the needs are going to be, from a security standpoint, from bandwidth standpoint. Performance and everything like that. I mean, Photon Cloud might work really well for some people that don't need super high frame rates or resolutions, things like that, and they just want a real quick plug and play thing to use. So, you can use that. Now, of course, with the self-hosted server, if you need to go to the other end of that spectrum and you need more, you have it. So right now, it seems to allow you to, do scale. It seems to allow you to do, free testing, and it seems to allow you, just have that ease of use if you want it. So I think going back, talking about this demo, this is essentially running an emulator inside of Unity, and it's a fun demo. It makes this game online multiplayer. We could actually, if I sent the client to somebody, they could just join this right now, and we could be playing the game. I could join from, 2 other computers could join this. So right now my Mac would be considered the caster, and then we could have 2 controllers join it. And this setup, I think, is very similar to what Kevin and the team at 900 pounds is using for their stuff, only they're streaming at, much higher resolutions and, newer, more crazy content, not a 30-year-old Super Nintendo game. But I think they're looking to be streaming 4K. And I told Steven last night that actually there is an option if you wanted to stream 4K, you could do that now, which you can experiment with that. I'm not sure that it's really ready for prime time yet, but it works. So I can actually stream this game at 4K if I want, and you can see the frame rate dip.
Yeah, I think as far as streaming 4K is concerned, it's a bit out of it's more of a want than a need, really, because most end user hardware is only going to be like 1080p displays.
Yeah, that's true. I guess you're going to be exceeding your end users anyway. So I'm going to run it at 4K right now. I mean, it's not going to look a whole lot different, and I don't know how it's going to do with Zoom running at the same time. So there you go. That's 4K. That's this thing streaming 4K to and from my server. It's going over the internet, so
that's great.
But yeah, your frame rate there. When I'm running this normally without Zoom, I'm usually getting somewhere between 10 and 15 frames per second at 4K. So the performance here looks like it's doing a little bit worse, but It's, I mean, if you wanted to use it, you could. I'm not going to recommend it necessarily yet, but it's functional. So I was happy to be able to do that. I'm thinking about your all's use case.
Yeah, I think for most of our use case now, we're going to be streaming at 1080p, but I mean the content in Unity we can still have at 4K, though with our demo to the rest of the team, we've let them know that no, this is something like we'll have to design for. We can't just take like a 4K application and then have like 1 pixel width like strokes and expect that to show up well on a 1080p stream. Like that's just not how that's going to fly.
Right.
Yeah. So
that's pretty cool. I'm glad, like, for me to hear somebody saying, "Hey, we're actually going to design around this," and all that's super exciting, because I think that's a sign of, like, hey, this is serious. There's serious implication for using this, and it's a strong value proposition. You know, like strong enough for you to think, like, hey, we're actually going to design software around this concept.
Yeah, definitely.
Which is pretty awesome to hear.
I did have a question though about the DLLs. So
Yes.
right now we're sort of trying to find a balance point between having the client use an application versus WebGL,
Mm-hmm.
and obviously there's limits on the WebGL build. We're probably going to get less frames, obviously,
Right.
and also, but that comes with the trade-off of it's super convenient for a client to click on a link, right?
Yeah.
If we host it on WebGL. Now, when we were working on this previously, we had to swap out the DLLs for StreamSDK, the actual StreamSDK DLL for WebGL.
Yes.
Now, is there anything that sort of at least helps identify the difference between those DLLs, or makes it a little easier to swap between? Like, for example, if we were trying to do something like, oh, well, let's see the difference between application run and then WebGL run, and then having those DLLs just to swap between while we're developing.
The way that I am starting to approach that, because as I go and test the demos before I put every release out, I have that headache of going back and forth. And now you're still seeing my screen, so you can see the core folder here, which is where all the DLLs are located. So you actually have the main StreamSDK DLL here. Then you've got WebGL inside of this folder, and then you've got the Windows inside of this folder. So there's actually a Windows version of this now, which for the new compression technique, there's actually a separate build of that. And so if you're building for Windows, you need that. If you're building for GL, you need that. If you're building for Android, Linux, Mac, iOS, you're going to use this. And to manage the DLLs, obviously you have Unity's import settings here on the right in the inspector. So this I basically say, hey, any platform, use this, but don't use it on WebGL. WebGL is kind of the opposite here, where it's like any platform, no, nothing except include platform WebGL. And then on the Windows side, I basically have that set to just nothing right now, because I'm running on Mac, so I don't want to use the Windows DLL.
Gotcha.
And what I've done is, so obviously use the import settings to manage that, but even inside the demo, so with the base folder, because WebGL is different enough, I've actually gone ahead and just said, hey, here's this WebGL version of this scene. So, check that out, because it actually is different enough that I built a separate scene for it. And something I realized as I was doing some more audio optimization, so your use case, sort of prodded me to start looking a little bit deeper into the audio. And I've got the audio better now, and I've got a solution that'll be coming in the next version that I think will solve some of the audio issues that we're having on GL. And we'll sort of get rid of any artifacts that are going to be in the audio at all. I came up with a method for other platforms that essentially remove all artifacts. And so this is the highest quality that it's been up to this point, and it'll keep improving. But so I was really excited about those changes. Nevertheless, when you compare, say, the base 3D scene, normally you'll see we've got an audio listener here. And something that cropped up as I was building this WebGL demo is I realized WebGL, actually, if you've got an audio listener attached here, or actually in the scene at all, as soon as you connect to another client, the WebGL build will freeze. And the funny thing is, you don't actually need an audio listener in the WebGL scene to hear the audio. And so what I ended up doing is building this scene, removing any audio listeners. There's a README here to sort of describe to you. this is actually old README, but there's a new README in the new 3.2 update, and it sort of fills you in as to what's going on there. But as I go further and further, probably the base 3D is where I'll do most of this stuff to try to show the differences between platforms. I mean, the scene is essentially the same thing. You just happen to be, you know, this version of the DLL is linked here to WebGL. So you can see when you click on that, you know, if you go back to this, say the standard base 3D scene, and you click on this, you'll see that this links to the version of the DLL that's in the core. And, you know, I could certainly run out a Windows version of this and say, okay, well, you know, let me save this scene as base 3D Windows, and it just makes it would make it a little bit simpler for me to jump between these things. You know, you could also manage it probably using prefabs if you wanted to. And I only see this, unfortunately, I don't say really unfortunately, but sort of diving off the core use case of StreamSDK. And as we get further and further into trying to, you know, extend functionality or extend performance, we're gonna be looking for more and more custom solutions, like the way that the 3.2 update is custom. It sort of moves beyond some of the core functionality, looking to get additional performance and libraries that do things that aren't done by default. So this type of stuff's going to happen. But you know, right now, okay, so right now that's still pointing to that DLL. And what I'm going to do here is I'm actually going to, so I'm going to build a Windows version of this scene. So what I want to do is come into the Windows version of the DLL, and I'm going to enable this thing first. So I'm saying, you know, include the editor right here, so that the editor is now going to use this version of the DLL as I'm working with it. And you'll see it, Unity's compiling down here on the right. Now all of a sudden we've got this Microsoft Visual C# compiler error, and that's because we have two versions of the DLL currently active. Now what I have to do is shut this one off and say exclude the editor on the standard core version. And you'll see when it's done compiling down here, you'll see on the bottom left, this error will go away as I shift over to that. All right, so that's gone. And now what I can do is I can actually drag and drop this version of the DLL. And so I'm going to take this, I might actually build, I'm going to drag, first of all, I'm going to drag this here, if it'll let me. Why am I having a hard time? Doesn't want to let me drag it. Oh, there we go. Okay. I've noticed Unity's been finicky with that blue line lately. Oh, I see what the problem is, because it's a prefab. So I'm actually going to see, I'm going to drag this transporter out. I'm going to break this prefab real quick, so I don't have to deal with that. And I'm going to copy my old component, and I'm going to paste the values here. And I'm going to drag this up and just get rid of this, the old version. Now when I click here, this points at the Windows version of the DLL. And then I'm going to call this guy StreamSDK Windows. Put my transporter back in there. And well, actually, let me create a prefab first. Because I think I have, yeah, StreamSDK WebGL. Did I make a Windows version? Oh, check that out. I already made a Windows version. So I do have a prefab of the Windows version there already. I think that points there. So I actually already did that. Look at, I'm ahead of myself. But I just took the steps to show you how I did that, how I made a separate, you know, prefab and game object that then references that. And so I can sort of just put that back together now and say, all right, cool. Now I've got a, you know, Windows version of this, and I can, in fact, I'm going to overwrite this. Don't overwrite that. I'm not going to overwrite it now because I have my keys in there, but I can go in now and say, okay, cool, save this as the base 3D Windows demo, which I think I already had. So cool, in place. So now when I go to my demos, you know, I've got standard base 3D, I've got Mac. Mac is for a different reason other than the DLLs, and there's some information in the README about that. It seemed to have a limitation on the number of cameras I was able to layer on top of each other, and it shouldn't have had that. It had to do with layer mask. It seemed like a rendering glitch. So there's the WebGL version, there's the Windows version. You know, basically these three versions of the scenes are there just because they're different DLLs. And so to make things, you know, simple on yourself, you could have separate scenes if you wanted to. And these scenes are all managed with prefabs also. So this makes it really easy to manage your scenes, but you know, this shell prefab, if I'm using the shell, whenever I edit the shell. I don't tend to do it in the scene. I tend to now just come in the prefab and edit it. And then those changes will basically percolate through all of my scenes. And that makes it, that makes it super simple to manage that. And even content, if I have some content that's going to be the same between all my scenes, I just, adjust the prefab, and then I get those changes in all my scenes. Or you could build one of those versions out, whatever's going to be your lead version. And then you can, at the end, say, okay, now I'm going to swap out the standard StreamSDK library for the Windows version or the WebGL version. And then just basically make a new scene with that change.
Awesome. Oh, it's much appreciated now that it's so much easier to swap DLLs between switching platforms. That's something we tend to fiddle a lot between. Oh, well, we'll try this platform or that platform, etc. So I'm really happy to see that in the new version.
Yeah, definitely. Managing DLLs, I think, it's a little bit of a chore, and I think Unity's done a good job of making it, they've done a good job making it manageable, but I don't know if it's the optimal solution. And, I'll tell you what, as I work with this, I think I'll be thinking in my mind how I can manage multiple libraries like that and see if there's a way to make it, even easier to where you really don't have to think about which library you're using, and that it will, there's got to be some sort of auto detection we can look into to say, okay, you're just going to use this one version of the library and it's going to pick up on these other changes. On the back end, of course, we're using preprocessor tags to access certain features depending on operating system and so on and so forth. So I'm thinking there could be sort of like a wrapper for the DLLs, something of that nature might actually get rid of that problem to where you could just rely on one. And that wrapper wraps all platform versions of the DLLs. So definitely something to keep an eye on. But are there any questions? Just sort of generally speaking, I'm sort of going around here trying to give an overview. Did everybody see the how it works doc that I put up? Because I feel like at a sort of like 900-foot view. 900 pounds, you got it here in my head. 30,000-foot view, I think would be more appropriate. This guy, which I showed to Nathan, and he told me I need to work on this, so I will. I'm going to take that advice, but I haven't done it yet. Essentially, any platform here can send its data. You've got your content layer, and obviously there's a content object in the scene. You don't need to use that content sort of methodology if you don't want. That's it's up to you if you want to use that or not. It was sort of an easy way for me to communicate to new developers kind of what's going on there. But basically, hey, you're streaming this content on the StreamSDK component. You're going to choose your camera, your stream displays, your input axes, and I can sort of, I think what I want to do is layer that and sort of show, okay, this is what's going on in the image, and then here's what's going on in the scene. I click on my StreamSDK component, and right here, sort of at its simplest, this is what the component looks like. Set my keys up, set my axes up for this game. I'm gonna actually jump to the let's see here. I'm gonna jump back to the retro stuff real quick, just so I can show these axes. So these are the axes for the Teenage Mutant Ninja Turtles game. So basically, now I've got the A, B, X, Y, D-pad. These are the axes that I want to stream across the network. So I set my axes up so I can control the game over the network. This is the camera I want to stream. This is where I want to receive a stream. In this case, the caster never really receives a stream from over the internet, but when you're testing, it is going to display on here. So there's a test mode that you can access, and basically it's going to route the data back to itself. And I want to be able to display that on a stream as if it was remote. So that's, this is your StreamSDK component, and we've got these advanced options here, which try to mask some of the complexity that's going on. But this is where you'll sort of get into the weeds when you're trying to get optimal performance, optimal, whether that be, visual fidelity or, visual style, whether it be the performance of your frame rate, so on and so forth, the performance of your bandwidth. We're using different levels of compression. Your UX, we're using this clone layer, which also is related to performance, your audio type and stuff. So you can get in the weeds there a little bit, and all that's in the documentation. But then we jump over from the StreamSDK component to the transporter, and I usually just link the transporter in right under the standard StreamSDK component. and transporter, this is kind of where the network routing happens. So I've got my content container highlighted here, but you don't need to use that. Like I said, in the SwapFire demo, I don't use the content container. I don't use the StreamSDK shell. None of that stuff is there. SwapFire is just running, and anybody can instantly connect to it and take control as if they were, just jumping onto a game console with a controller and taking control there. You select your net tech. In this case, I just have Photon listed, but if you dive into this wrapper, you'll see some hooks for TNet that are commented out right now. The number of receivers that you're going to expect to connect. Override Photon server. So there's some code, and I think it's in the Photon Wrapper, and it gets passed from the transporter to the Photon Wrapper. But essentially, you can override Photon server, and Kevin knows this, but there's an asset in here called Photon server settings, and so this is where you normally set up your Photon stuff. If you want to override that and then put all that information in code, you can do that as well. So reload scene, in this case, I'm not reloading my scene between takes. I'm just using one scene that's non-reloading, and then it either instantly streams or doesn't. Room name, SNES, send rate, I want to send it 60 network frames per second in this case. Test mode's off. And then send data. I think this is where it gets really interesting. So there's this send data array that allows me to choose who gets what data that StreamSDK produces. And in this case, it's set to 2, which means I'm going to be sending out, basically 2 streams to the first 2 people to connect to me. And I'm only going to have 2 receivers, to tell you the truth. So I've got 2 receivers, and I've got a send data size of 2 in this particular scene. This is the casting scene. And what I want to do is I want to send the stream. So if you have stream checked, what it does is it actually consolidates all this data into one packet, which can be useful if you have packet limitations on your server. And I think in some instances, too many packets can be, maybe perceived as like a DDoS attack almost. So I've noticed though that there's a balance to this. If you're appending too much data into that packet, you might actually have to break it up. I ran into an issue where I was testing, and I actually needed to say, don't send the stream, just send the audio and video. And what that does is it actually breaks up the audio and video into separate packets. And so those packets will be smaller, but you're going to be receiving more of them because now you're sending, instead of 1 packet to represent all that data, you're sending 2 packets. But essentially the way to interpret this is the first 2 clients to connect to me, the first client's going to get this, the second client's going to get this. And, generally speaking, I'm just going to be sending the stream over. And as we go from the transporter sort of down and wrap, what we're going to dive into next is, well, this thing is using Photon, and where does that happen? So what this does is this actually relies on this script called the Photon Wrapper. And this is where the actual Photon action happens, is inside of the script. I think by default, you'll have to comment out this line up top. I actually have it uncommented, the define submit. So usually it should be whenever a build goes up and out, if you're pulling this off of GitHub or you're pulling it off the website, you'll have to come and uncheck that thing. So that the actual class, there's like a dummy class at the very top. And that's just so that you don't get a bunch of errors when you pull this in and you don't have Photon imported yet. So just to make that a little simpler on you, once you get Photon installed, then you can uncheck that or uncomment that out and it'll just work. So the Photon action kind of happens in here, and any network tool, essentially, whether it be TNet or others, they all have basically the same functionality. It's all done a little bit differently. But generally speaking, you're going to be connecting, you're going to be disconnecting, you're going to be sending data, so on and so forth. And so the StreamSDK transporter is there just to wrap whatever that specific code is, so that whenever you're working with StreamSDK, hopefully you're just using StreamSDK transporter.connect or disconnect or quit or whatever the command is, and you shouldn't have to really worry about diving into this layer. This layer is all taken care of by the transporter. And one other component, I don't have it here in the how does this work, because this really explains, I think, more mechanically how the networking and the streaming is going on. But there is another component which Kevin, I think, is pretty familiar with, which is the UI manager. And this is essentially just how StreamSDK manages, it makes it easy to manage the shell. But if you're using the UI manager here, these are the different game objects that the shell contains. And it's just a real quick way of saying, hey, show me the main menu. And when you show the main menu, it's going to hide everything else. Also, the app's resolution, full screen, and et cetera, are just managed from this thing. So if you're using this, like these settings that I have here are going to override anything that I've got in my project settings. So when my app boots up, if my project settings say, hey, run this at 1024 by 768 full screen, it's going to boot up like that for a second, and then this script's going to run, and then it's going to say, no, actually make it 1280, 720, and put it in a window. And so whatever settings you put here really be how your app runs. I think Kevin found that, you can run the app like this. You can still stream whatever resolution that you want. That's kind of the neat thing about it, is that I can run this thing at 1280 by 720 and still sort of raise and lower the resolution of my stream to whatever I want inside of that window. Now, I might want to blow this window up if I'm going above 720p. But if I want to run a 360p stream inside of this resolution, hey, no problem. I'm just going to be saving on bandwidth and frame rate and stuff like that, and it'll just work.
Hey, Jeremy.
Yeah.
This is Nathan. I got to go for another meeting, but I appreciate your time. It's been very informative. Thanks.
Thank you so much, Nathan. I appreciate you being here, man.
Sure. Best of luck. Bye.
Bye-bye. And let's see, with that, any questions? I think I kind of got to do the walkthrough that I've been picturing in my head, and I just want to make sure that makes sense to everybody.
Yeah, that was great.
I appreciate that, Chris. Any questions coming to mind as I sort of roll through this?
This looks really great, man. It really does. It's a really cool layer for what we're working on in Unity.
Sweet.
Yeah. Well, I've got all my questions you answered.
Awesome.
Yeah. So the DLLs is the one I'm really happy about, and the new better resolution and performance at higher resolution. It's pretty good. It's pretty sweet.
Yeah, I think you're going to be pretty happy. I know as I was working on that, when I finally got it to the working, I was like, kind of, yes, this is what needed to happen. And I've got some other experiments going on to push it even further. But for right now, this is definitely going to, especially for what you all are working on, I think is going to be a really big improvement on those projects, and hopefully help you out a lot. So I'm excited about it. Great. If there are no other questions, I think I'm going to go ahead and call it a weekend. It's 3 o'clock here, and I really appreciate everybody being on the call. If there are any questions that you have right now, voice them, or just shoot me an email or message on LinkedIn, and I will be sure to answer that as soon as I can.
Thanks.
Awesome.
Have a great day.
Thanks for the demo. Really appreciate it.
Thank you so much for being here, and everybody have a great weekend.
All right. Cheers, man.
Bye.
Bye.
Bye.